Okay, our final problem of this section is page 432, number 23. We're asked to solve algebraically for the exact solutions in the interval 0 to 2 pi of cosine 2x plus cosine x equals 0. Now we want to use the same type of strategy that we used for the other problems in section 5.1 and 5.2. We want to have common factors that we can set equal to 0. Now the problem with this problem with number 23 is the fact that we have a 2x here for an argument and an x here. So we can't just factor out a cosine. We have to write cosine 2x in terms of a trig function that is not a 2. We need to have an x, so it looks like cosine. So what we're going to do is we are going to use the double angle formula, and we're going to use the one that involves cosine. So we're going to rewrite cosine 2x to look like this. So cosine 2x is 2 cosine squared x minus 1. And then we have our plus cosine x, and that equals 0. So I'm going to rearrange these terms, and hopefully you can see that this is a perfect square. Well, not a perfect square, I'm sorry. This can be factored into 2 cosine x minus 1 times cosine x plus 1. If you were to multiply this, you would see that we would get, there's our 2 cosine squared. Here we'd have a plus 2 cosine x, and on the inside terms we'd have a minus cosine x, which would give us our cosine x, and then we have our minus 1. So now we have our two factors. So setting those equal to 0, we're going to have 2 cosine x minus 1 equals 0, and cosine x plus 1 equals 0. So when we solve for cosine, we get cosine x is a half. So those angles in the unit circle happen at pi over 3 and 5 pi over 3. And when we solve cosine x plus 1, for cosine x, we get cosine x equals negative 1. And that happens at one place in a unit circle, which is at pi. So our solution set is going to be pi over 3, pi, and 5 pi over 3.